So for the next problem, we have a sum of torques that is given as from the motor on the grindstone to be 10 Newton meters, and the moment of inertia for the motor is 2.0 kilograms meters second squared. The system starts at rest, so that's I initial equals 0. And then we want to find the work done by the motor in the time of 8 seconds. So, what is the average power delivered is what we're asking, and if we use the fact that the sum of the torques is I alpha, then alpha equals the sum of the torques, so the torque over I, which is 10 Newton meters per 2 kilogram meters squared. And this gives us, remember what a Newton is. Newton is a kilogram meter per second squared, so this gives us per second squared, and it gives us 5.0 radians per second squared. If we want to find the power, remember the power was, we call power, P was F sub D, so in rotation the power would equal, instead of the force we have the torque, instead of D we would have theta, right? So we need to find what the distance is, and we can use constant acceleration rotational equations. So if we used the following one, right, we've seen this one before, we know again that we can start from 0. We're told that it starts from rest, so the amount of angles swept by the grindstone is 1/2 alpha t squared, which is 1/2 times 5.0 radians per second squared times 8.0 seconds quantity squared, and that will give us about 160 radians. And now to find the power or the work, we can say this should have been work forward. Work, not power. Sorry about that. The work is the torque times the angle that is swept, and the torque we know is 10 Newton meters, and the angle we just found is 160 radians. So this gives us 1600 joules of work, and the 1600 joules of work, now we can say that the power is the work over time. So this is going to be 1600 joules for 8 seconds, or 200